Let's now open a defined, simplified representation of the digital mower model. The preview function helps the user avoid mistakenly bringing a large model into the session. Let's switch to the combined views to review the model. The combined view can include orientation, a simplified representation, an exploded view, and/or information about layers. The on-demand simplified representation can interactively remove components in and out of memory when selected. Here the selected component is in the graphics representation mode. Notice that when we activate the part, it automatically turns it into a master representation. But once we cancel the change, it will go back to the graphics representation. During the product development process, an increase in top-down design methodology has been used in various industries. Creo Parametric provides a 6-stage top-down design solution for product assembly. Designers can use the Layout tool in Creo Parametric to plan the top-level requirements, define space allocation, and capture the key design intent. The second stage will create the initial product structure, which is the foundation of an efficient distribution of the design task. In this process, only the empty parts need to be created, but all the resulting product structure can be managed immediately in a product development system, such as PTC's Windchill PDM-Link. The third stage is to capture the design intent. Creo Parametric will use a unique solution, skeleton modeling, to capture the design parameter and control the object's interfaces. The fourth stage will be managing the independent relationships between various design objects. We'll take full advantage of the parametric and associativity functionality of Creo Parametric to manage efficiently independent or dependent objects to ensure our design intent. The fifth stage is to communicate the design intent. The top assembly designer can easily distribute design task and intent to individual groups by using Creo Parametric's skeleton modeling to copy and distribute geometry functions. It will ensure the efficiency and quality as well as reduce the design complexity. After all the 5 stages are completed, we will go to the 6th stage, which is the assembly stage. Let's simply go through the design process I mentioned above. We will start by creating a skeleton model. It includes all our design intents and many of the key parameters. You will see the design information such as the sketch, surface, and benchmark interface. In addition, Creo Parametric supports a unique skeleton model, which is the motion skeleton. The advantage of this model is that we can use it to easily and quickly validate the mechanism by inspecting the range of motion and interference. In a lawnmower, the front deck can move in the forward, backward, or up and down direction. We will focus on the deck height from the ground and the distance between the rear wheel and the deck. We need to make sure the distances are large enough to avoid a collision. Now, let's switch to the mechanism analysis module to analyze the kinematic of the motion skeleton. In this analysis, we can see the movement of the deck and the distance measurement. We are also shown a distance time graph chart of the deck movement. This makes it very easy to work with the motion skeleton in order to evaluate the design. The geometry information of the mower frame and deck is controlled by the skeleton model. Therefore, we can modify the geometry on the skeleton model and all the changes will be automatically propagated to the other related components. Let's change the length from 7.8 to 12 and increase the width of the deck case from 39.5 to 43. We will see the changes after regenerating the skeleton model. Let's go back to the assembly and switch to the top view to have a